morning, dear students. Again, we are starting the continuation of the previous topic. That is, in the topicity we have discussed so far homotopic ligand and homomorphism, topicity. Now we are going to discuss what is heterotopic ligands. What is heterotopicity? Atoms or groups are separate replacement of which with the different atoms or groups. Suppose if you have a molecule having C, Cl, C, Cl. Okay, their connectivity is not same. Whereas if you consider this molecule, carbon, a single carbon is attached to two different ligands. Okay, the connectivity is same here. So, separate replacement of atoms or groups which are not present in a molecule. You replace chloride with some other X. You replace this chloride with some other X. Okay. So, you are replacing a chloride not with the same atoms or groups which are already present in the molecule. You are replacing it with an external group. In heterotopic ligands, you will see here, if you replace this carbon double bond or carbon single bond attached to Cl and this is attached to Cl. Okay. Now replace one chloride with X. Now replace another chloride. You get two constitutionally same isomerism. They are constitutional isomers. The groups are same but the arrangement only is different. Those type of isomerism we have discussed in our previous classes itself. They are called constitutional isomer. The connectivity is not same. Here connectivity is not same. Whereas here connectivity is same but they can give rise to a stereochemical isomers or stereo configurational may be different for these type of molecules. Here they will give rise to a constitutional isomers. Here they will give rise to a stereochemically different isomers. So this is called stereochemically heterotopic and this type of molecules are called constitutionally heterotopic. Again, when you say if they are stereochemically or stereospecificity, selectivity, we have discussed that. If you call it as stereochemically heterotopic, that heterotopicity will give rise to two different type of isomers that are, one is enantiomers and another one is diastereomers. Okay. Now, in the constitutionally different isomer, you have plenty: positional isomers, functional isomers, metamers, tautomers. All these will be coming under constitutionally heterotopic ligands. Okay, for example, let us consider a molecule. Okay, let us consider a molecule that is carbon double bond carbon attached COOH acid and attached to one methyl group. Another methyl group is there and again it is attached to hydrogen. Now let us name these carbons as C1 and C2. This is carbon C1, this is carbon C2. Okay, they are constitutionally heterotopic ligands. They are constitutionally heterotopic. Ligands. Now replace with the C1 methyl group. Replace C1 methyl group by X. Now what do you get here is carbon double bond carbon, COOH, an acid group. This methyl group remains the same and here you have, it is replaced by X and hydrogen. Okay, again replace C2 carbon by X, C2 methyl group by X. Now carbon carbon double bond, COOH, X, hydrogen, CH3. Actually, they are forming two different constitutional isomers. They are forming two different constitutional isomers. So they are called constitutionally heterotopic ligands. They are constitutionally heterotopic ligands. Now let us consider another cyclic molecule such as substitution cyclohexanes, substitution cycloamines, etc. Suppose again you have a molecule, okay, nitro group is present. Again you have here one hydrogen. Again you have here another hydrogen, H1 and H2. Replace H1 by fluoride. When you replace, what happens here? You have NO2. H1 you are replacing by fluoride. Rest of the molecule remains the same. Again replace H2 by fluoride. Okay. NO2, H1 and F. One is forming an orthofluoro and another one is forming a metafluoro. One is forming metafluoro. Okay, so they are called constitutionally heterotopic. They are constitutionally heterotopic ligands. Okay. Now another important topic what we are going to discuss is enantiotopic ligands. Okay, we have discussed what is homotopic ligands, what are heterotopic ligands. In that itself again we have another important concept is called enantiotopic ligands. What are enantiotopic ligands? Okay. Third important topic is enantiotopic ligands. By replacing any atoms or groups, we get two types of isomers that are called enantiomers. By replacing any atoms or groups, we get two types of isomers that are called enantiomers. The ligands are called enantiotopic ligands. Okay, now let us explain this enantiotopic ligand with a molecule. Replace one hydrogen. For as easy sake, we will write one is with black, one is with red. Okay, one is with red. Okay, now replace this red hydrogen by X. Then you get a molecule COOH, X, hydrogen and CH3. Okay, where this hydrogen remains the same. Again replace the another hydrogen with X. COOH, CH3. You have hydrogen here and here you have X. Now let us think of the configuration. I have taught you earlier itself the CIP rules which you have to apply to assign a relative configuration for the molecules. Okay, now what type of a, first of all here just remember, it is not a stereogenic center. Basically the original molecule is not a stereogenic center, but by replacing one group you are having first of all an important concept is you are getting a stereogenic center. Stereogenic center. Okay, now just consider the configuration. What is the priority of the groups? Let us consider the priority of the groups. The first priority is COOH and the second priority is um, to CH3 to CH3. Then you get here an S conf. Okay, one configuration you get here. Okay, this maybe you will getting an S configuration. This you will be getting an R configuration by knowing if X is greater than H or etc. So these type of chiral center is generated and they are mirror images of each other. They are mirror images of each other. That's why they are called what? Enantiotopic ligands. Because of the presence of the ligands, a molecule is which is not a chiral center is generated a chiral center. Okay, chiral center is being generated. And the next example, and easy to understand another example is suppose you have carbon, you have here chloride, you have here hydrogen, again you have hydrogen and hydrogen. They are differently substituted. It is not having any stereogenic center allene. Okay, differently substituted allene. It is called differently substituted allene. Now replace HA. Okay. Now replace this H by Br. Okay, this red hydrogen. Now what you get is carbon, Cl, hydrogen. This red hydrogen only you are replacing with Br and you have again this hydrogen remains the same. Hydrogen. Now replace this black hydrogen by bromide. Carbon, Cl, hydrogen, you have bromide and the red bromide is actually it remains as a hydrogen. Now what happens here? You have a constitution two different enantiomers. They are mirror images of each other. Okay, so these are called actually enantiotopic ligands. Enantiotopic ligands. Okay, and NMR is enantiotopic ligands are equivalent chemically. They are chemically equivalent. Now, for example, you can draw enantiotopic ligands for another important molecules. This you can draw your homework for you. That is, suppose if you have here a molecule. Hb, hydrogen, replace by Ha with one group, maybe Br, and replace Hb with Br and write one thing. Again, you can have another group is here one hydrogen, here one hydrogen, here one CH3 group. Okay, you just see how by replacing these hydrogen atoms Ha and Hb you get a different molecules. You just go through it. Okay, now symmetry criteria. Another important factor is how do you identify symmetry criteria for the molecule. Okay, symmetry criteria notes I will give you. You please go through this symmetry criteria and make sure that you are understanding. And different model questions also I will be giving you along with this thing. Okay, notes will be attached here.